Alright, so I'm going to be going over my Mips processor project that I did. I actually did this project in grad school, but I wanted to redo it. When I did it in grad school, I kind of did the whole thing in one Verilog module, um, and I wanted to go back and do it kind of the right way as I see it. I wanted to split up each of the components into single modules. That way you can see what each individual part of the Mips processor is doing, and logically actually figure out what the thing's doing instead of looking at one giant block of code. You have several files, um, and it's just better for troubleshooting and pretty much understanding how the thing works. Um, Although this video is going to be mostly about just the GUI I developed in Python. So I'm going to go ahead and run that program now. And I'm going to navigate using Cygwin. This is basically a Linux terminal, but it's running in Windows 8. I'm just a big fan of the Linux terminals as opposed to the Windows command shells. So anyway, um, so you can see you can do ls and all those commands. So I want to go to my Mips processor, Mips, and now you can see I have all my files, a lot of Vivado files, which are Xilinx RTL coding tool. Essentially, it's an IDE, but this is some of the extra files that it generates, logs, things like that. So I'm going to go ahead and run my Python program. It's this mips py file. It's a Python script I wrote to run the GUI. So here you can see I'm typing py mips.py. This py keyword here is something I put in the bashrc file. It's an alias. So when I type that, it's actually telling me to run the Python exe. And so every time I type that, it'll do that. So I can just type that and hit enter and it will run. Now you can see my GUI popped up. It's got the nice Mips technology logo. I have buttons here for the single cycle, multi-cycle, and pipeline processor. So go ahead and click the pipeline processor. As you can see here, there's a lot of pipelining going on if you're familiar with the concept. Each of these signals get delayed through the clocks and passed through the system. I actually haven't completed this part of the project. I did it back at school, but I'm redoing everything from the ground up. So mostly this was just to show the GUI working. But here you can see I have individual buttons at the bottom, and each of these buttons are for just opening up the Verilog files. So if I click on this program counter right now, it's going to open an empty file. So I won't click on that now. We'll go into the more interesting ones. Again, I have the multi-cycle, and I haven't finished the multi-cycle. What I have finished, well, as you can see here, I click the program counter, so that'll open up program counter mult.v in my Notepad++, which is my favorite text editor. But yeah, I haven't typed anything up in here yet. Still working on that portion of the code. However, if I close that out and open the single cycle processor, I have completed this portion. I plan on completing all of them, but I wanted to get to a point where I could prove that I could do all of this in the GUI. So for example, again, I'll click the program counter and it will open Notepad++ again, which is my favorite text editor. And you'll see the program counter and the Verilog code in here. So go ahead and actually close that. And we can look at other things like the top module. It's fairly interesting. You can see all the instantiations. It's not doing much in the way of Verilog code, but it is instantiating all the other modules. So yeah, go ahead and close that. Another thing that I added are these two buttons here, Quartus and Vivado. Quartus stands for Quartus 2, basically. It's Altera's IDE for editing RTL behavioral code, synthesized code, and implemented code for FPGA designs. Yeah, so we'll go ahead and click that, and it'll open up that IDE with the project. It'll take a little bit, but it should pop up pretty quickly. there we go. Just took a little bit, but now the software is running, so that's always a good sign. I have the buttons linked to the exe files, so we can open up whatever we want to run. And now you can see it says single cycle Mips up here, so it is looking at the right project. And another thing to mention is these projects, all the files in these projects are going to be the exact same files that we're opening in Notepad++ that's accessed from the buttons on the main screen of my GUI that I wrote. So here's my test bench. It instantiates my Mips processor, which instantiates all the internal modules of the design. So I can open up data memory, for example, and you can see it here. And I need to have it get initialized to something, so I do that on the reset. It's not, again, it's not about Verilog code. It's just about the GUI and the design of the project. Let's see, there's another one I wanted to show off. Instruction memory. Yeah, there we go. For this, I just wanted to show that I have 9 instructions going through my design right now, and they're just the R-type instructions. I wanted to get to a point where I had a running processor that did a few instructions. So I have about 9 instructions working on this processor now. All right, so I'll go ahead and close Quartus. And then we'll go back to my GUI. And we'll reopen the single cycle processor. Easy to see the drawing, so if I'm doing any design on this, I can just go and look at this and see what I need to work on. Or added functionality I can add to the drawing later. But yeah, so now I'll open Vivado, which is Xilinx. Xilinx's equivalent IDE for RTL development. And you'll see this one, I think it takes a little bit longer, and you'll see it'll pop up with some writing here in the Sigwin terminal. It says start GUI, so that's a good sign. That's what I want to happen. Vivado 2014.4, and I haven't updated it for a little bit, but yeah, that's all right. We'll get there. So now you can see the main window. It has all my recent projects. Here's my graduate design project, the DDR3 SD-RAM controller. That was a fun one. A lot of work. So, and soon you'll see here, the project will open with all the files. The test bench, instantiating Mips processor, instantiating all the files, and we can go ahead and open any one we want. We'll go ahead and open the register file. And although this will edit the same file, this isn't the same text editor. This isn't Notepad++. This is internal to Xilinx's tool. So I can edit it in whichever ID I want pretty quickly. If I make a change in this file, it changes it across the file that is accessed in Notepad++, that's accessed in Quartus 2, and that's accessed here. Because they're all linked to the same files. I thought that was really important. Alright, so we'll exit Vivado. I'll show you guys one last thing. Again, in the single cycle processor. So in each of those IDEs, you can basically run behavioral waveforms so you can see what your Verilog code is actually doing. For this one, I wanted to make a button that kind of skips that process so you don't have to open the IDE every time you want to see a behavioral waveform of your design. Because a lot of times people want to see your design, they say, well, what does it do? And so you want to pop open a waveform and show them right away. So I have this button here that goes straight into Model Sim, which is specifically a waveform viewer. Go ahead and click that. And this guy takes a little bit to run. They're big programs. So we'll give it a little bit. Alright, so vsim opens, and then you'll see Model Sim pop up on top of it. It's the Altera Starter Edition, so this is the kind that I am familiar with, that I did work with at my internship at Altera. Alright, so now we have a blank waveform. not exactly what we want. We want to actually see some signals doing things. So I actually have to run it. I could put it somewhere in the code that it has been run for, I don't know, 1,000 picoseconds, but it's just as easy to sit here and click this. You can either do 10 times, change this to 1,000 picoseconds, but I'll just click it so you can see the wave propagating across. And this is my clock and reset signal of my design. Again, so yeah, we have a clock and a reset. That's great. But as you can see, the program counter, the adders, all that, it's not doing anything. Actually, they are doing anything. The files are just not open yet, or the signals are just not open yet. You need to click this little plus button to see them. So this is a program counter. You'll see next PC and current PC, and it'll tell you the values. And this one will be offset by this one by a little bit. But again, I'm not going to go into the details of how a Mips processor works for this design. I'll just show you that I have it working with multiple IDEs and the model sim waveform viewer. Read data, you can see whatever you need. Write data, sign extension, control unit, ALU, all kinds of fun stuff. And I can go in here and I can troubleshoot my design as I go through. I can troubleshoot specific portions of it. So probably opening write data all 32 bits isn't a great idea, or read data. Because you can see them here. You can switch all these to hex or whatever you want. Anyway, so there it is working in model sim. So go ahead and close out a model sim. Thank you. Okay, so we're now back at my main GUI. So again, with this design, I can see where I'm at. So I can see that I have done all these by clicking on any one of them. It'll show up in Notepad++, and you'll see the work is there. Maybe I need to add some things, but it's working enough to generate waveforms at this point. And I have my Quartus and Vivado buttons here, so I know that's working. And my model sim button. So I can say, okay, the single cycle's done. And I go in the multi-cycle. Yeah, clearly I have work to do. I'm missing buttons. I'm missing modules, most likely. And if I click on any of these are probably empty or have very little code in them. So I'd have to go through with that. So that's where the next steps of this design is going to go. So I'll probably end up posting another video when that's done. Anyway, thank you guys for watching. I hope you enjoyed.